Hi, friends. Welcome again to another episode of Beyond the Clouds, Edge to Edge Transformation. It's always fun to talk to very interesting people, and one of them is Dr. Charles Shea of Needham. Charles, tell us about your journey.
Oh, thank you, Shankar, for having me. Really nice to be here. I used to work in the semiconductor industry. I joined Needham and Company 2019. But prior to that, I worked 6 years at Applied Materials. I got a job in Applied Materials. Well, very simple. I came to the US from China, where I did my undergrad at the Tsinghua University and did a PhD in material science engineering. And then as a material science engineering major, very naturally, a lot of the graduates gravitate towards semiconductor manufacturing. Either people find jobs at companies like Intel, Micron in the US, or you end up getting a job at the equipment companies. A lot of them are in the San Francisco Bay Area. That's where I got started. Later, as I went through several different kind of roles at Applied Materials and did an MBA back at UC Berkeley again, I went to Wall Street and became a stock analyst there. And it's been almost 4 years at the Needham and Company, and it's been fun.
I was fascinated by what you said in your introductory keynote at the Design Automation Conference last week, where you mentioned that for the first time, the EDA industry's fortunes are now getting decoupled from the fortunes of the big semis. Can you get into that a little bit? What's happening?
Yeah. So what's happening? Very simple. In the past, EDA is the EDA revenues. The market is really driven by the R&D expense, R&D budget of the semiconductor companies, because back then, the one who use semiconductors are not those who design semiconductors. They just buy off the shelf from either IDM companies like Intel or fabless companies like AMD, NVIDIA. But gradually, I think it became more significant in the back half of the 2010s, that the prior decade, that the companies who actually use the silicon feel like they want to design the chips as well. I mean, part of that is really pioneered by Apple. Apple is the one, right? That previously they utilized ASIC companies. Earlier in the 2000s, they used eSilicon as an ASIC service company to help them manufacture the chips for iPods. And then later they use Samsung, right, to use to design the chips that are used for iPhone, etc. But then I think in the middle part of 2015, I think everyone knows they transitioned from Samsung to TSMC. But the other thing is they completely insourced chip design to themselves. And today, if you look at Apple, they are the one who designed the chips, but they are not selling those chips. They just use them. They sell the end electronics. I think a lot other companies followed suit. Tesla made a similar move around the same time, and all the US big tech companies, Amazon, Google, for example, right? And they made and Meta, they made a similar move. So I think really going back to what I mentioned, for the first time, there is a decoupling of the EDA in terms of the revenue, where they come from. They no longer just coming from the semiconductor industry. They come from the broader tech industry that design their own chips. They don't sell those chips, but this is something I think somebody at the DAC I met with came to me after my presentation last year and said, "Hey, Charles, I agree with you. There's a big move from design to sell to design to use. And for EDA, this is great news. You're no longer captive to the semiconductor industry, you are part of the broader tech ecosystem. That's a much bigger market for them.
Very interesting. I also remember a memorable statement, which is chip companies are becoming systems companies, and maybe systems companies are also becoming chip companies. Do you think this is a temporary trend, or is this a long-term change in the way life is going to be in the EDA and in the chip industry?
Well, this has been a trend ongoing for, I would say, for probably a decade if we really start think about how Apple started getting into this chip business. And it's probably an irreversible trend by now. A couple of things. One, chips are becoming important, right? Really becoming important for all the systems companies. It's no longer the case that you can just buy the chip from the merchant semiconductor companies and you just focus on things like software or the overall electronics equipment design and manufacturing. That's no longer the case because Moore's law is slowing down. You actually can see the merchant semiconductor companies like Intel, right? For example, they're slowing down in terms of when they refresh their product offering. And this now there's something called a domain specific computing. Basically, the system companies start to find that they actually can design the chips specifically to their own application. I can guarantee you those chips they design for themselves are going to do a great job for their own application. But if it just you are the other company who buy the same chip from those companies, they're going to do a probably not so great job on the tasks you want them to do. So this is something called a domain-specific computing, right? But at the same time, what that means is system companies, they found that they can actually co-design the hardware and the software altogether. I think in EDA, for the EDA world, there's something called emulator prototyping hardware tools, which allow the system companies to really start designing the software, coding the software at the same time as they start designing the chips. So they start at the same time, they can finish at the same time, rather than they buy the chip and then try to tailor the software to the silicon. So that's a great advantage for them. So I would say this industry went through almost a full circle, right? 40, 50, 60 years ago, those who design chips are those who sell the end electronics. And then later, the specialization across the semiconductor supply chain started, right? That was like 40, 50 years. You first have ASIC business model, right? And then later you got there was an emergence of a fabless model, fabless foundry model, and then gradually even for there is this design services business model, right? That further carve out the semiconductor supply chain into smaller pieces. So every individual company, they specialize in their small piece, but they try to get as much market as possible. For example, TSMC, right? That they specialize in manufacturing. They don't do design. They become a dominant company in manufacturing. But now we're to a point, maybe the trend is reversing. Instead of everyone specializing their tiny little section of the supply chain, they start to vertically integrate back. And now Apple is a very simple example, right? Apple design it, let TSMC manufacture it, and then sell the finished product to consumers, right? So I think similar trend will likely play out as we enter this so-called AI era with companies I just mentioned, right? Google, Microsoft of the world. They design their own chips, outsource to probably TSMC, Samsung, possibly Intel Foundry in the future, and then deploy those chips in their data center. And they don't sell those chips. That's their secret sauce, but they sell the services, right? The cloud services to the end customers. So this is why I call that this is an industry going a full circle, right? From everything vertically integrated, then going to the super horizontal integrated, several parts, a very long supply chain. Now we're going back to this vertical integration. Really back to the point, right? On EDA, this is great news for EDA. I mean, some people think, okay, consolidation probably bad for EDA, but hey, look, if everyone is trying to design their chips to their specific application, what we're going to see in the future about the chip market is you're going to have a lot very high mix in terms of chips, but each of the type of the chip is probably kind of low volume by itself. But high mix of low volume, that's great for EDA because every design, one design is a design just because you're selling 200 million chips per year versus you're using chips for a few hundred Ks per year. Doesn't mean the job of design is any different. It's probably the same. So really going back to the point, I think EDA is in a great position to be the enabler of this transition for the industry, and also will benefit from this trend.
That sounds all good news. Now, if you go back 50, 60 years, and there were mainframes, it was completely vertically integrated. EDA was also part of IBM and AT&T Bell Labs, HP. Also, the manufacturing in many cases was integrated too because they made their own silicon. Do you see a scenario where the manufacturing or EDA becomes part of the chip? Is that even possible, or will they always be separate?
Well, the problem about I'm saying we're going a full circle, but we're not going completely back. I want to clarify that. That was a great question. Manufacturing is very difficult to quote unquote in-source. Saying, for example, there were speculation maybe Apple should think about build their own fabs, but the problem about that is Moore's law slows down, means it will require increasingly higher amount of investment for you to go to the next node. What that means is to go to the next node, you better have a limited number of companies who can pool the demand altogether so they can afford to do the R&D, to build the capacity, to move everybody to the next node. I think one great analogy here is think about utility. Utility companies, I mean, every geographical region, why is there usually only one utility company in California? Here is PG&E, right? Well, very simple. They need to build the grid. That's very high investment. The only way for them to get the proper return for that investment is they almost have the entire market. Same thing is happening in the manufacturing world. Going to the next 5, 3, 2 nanometer node, people will look at, for example, TSMC, why they have 90% plus market share. Well, they probably need that market share to be able to invest for the future because, like I said, very high capital investment to moving Moore's law forward because Moore's law is slowing down, which also means they probably need, I'm not going to say the entire market, but a good, very high market share for them for this innovation to going on. So to answer your question, I don't think manufacturing will be vertically integrated. It will likely on the design side, will be vertically integrated by the system companies. Manufacturing may stay standalone, will not be vertically integrated. But I will say this, in manufacturing, there are some vertical integration going on. I talked about that specialization trend, right? In the last 20, 30 years, there was a foundry that only does manufacturing and doesn't do much of the design, and then there's OSAT, outsourced assembly and test houses. A lot of them in Asia, they just focus on assembly and the test, right? But the consequence of Moore's law slowing down, the other consequence is you probably need to rethink about packaging as well. Packaging, you no longer you not just need the traditional packaging, wire bonding, flip chip. You need to think about advanced packaging and to move packaging forward. So you squeeze out that additional performance gain, power consumption reduction, and some area benefit when those PPA benefit coming from Moore's law is becoming a little bit diminished node over node because of the technical challenges at the silicon level. So you are actually seeing companies like TSMC, Samsung, Intel, they are vertically integrating packaging in-house. Well, I need to make an exception. Intel, I mean, for Intel, packaging has always been part of Intel, right? But for TSMC, they made that move probably 10 plus years ago, entering packaging. So now you're seeing TSMC actually starting to offer turnkey, right? CoWoS, chip on wafer on substrate, that has been the hottest topic recently. But more advanced 3D stacking, hybrid bonding, those are the things increasingly look like they have to be done by the foundries, by the ones who actually manufacture the wafers, so they can integrate those wafers, those chips properly. So that's some vertical integration going on the manufacturing side.
Exciting. We are in for exciting times as there's a slowdown in the geometries. Do you think it's realistic now that so much money has been poured in by so many governments from the UK, United States, EU, India, and many others, Japan? Is it realistic to have foundries in all these countries and to compete with TSMC, given that at the high end, 3 nanometer, 2 nanometer, it's ridiculously expensive and it takes time to bring up the yield? What is your prediction of what these foundries will do?
Well, I think I mentioned the kind of like a foundry, the consolidation, right? Why a few years ago, 28 nanometer node, we have a handful, or quite not just more than a handful of foundries you can go to. But now we end up only having 3, right? That's a natural consolidation because of that. The Moore's law slowing down, capital investment. I mean, minimum viable investment you need to make is going up quickly, and the foundries need a good chunk of the market to be able to sustain that innovation cycle. When government comes in, why the government comes in, I think it's a recognition of that natural consolidation is very hard to reverse. So what you end up pursuing is, well, one, you want to make sure there is always an alternative, right? There's always a TSMC alternative. But even when there's a future, let's say maybe there's a future when TSMC will become more dominant, you want to make the governments of the world, you want to make sure there is at least some geographical diversification there. If you can't really diversify from TSMC, at least you can get a manufacturing capacity, not just from Taiwan, right? Maybe from the US, Japan, and at some point, maybe from Germany. So I think that's what's going on right now. You can't really diversify the number of foundry companies. At least you diversify their geographical footprint. Like I said, I think Moore's law, that's the constitution for semiconductor industry, right? You can't be unconstitutional. And the problem about the consolidation is it's just a natural course because how the technology is evolving. What the government can do is try to at least make sure TSMC, Intel, Samsung, all these companies, they have some diversified manufacturing base. So just in case, right? The consequence for that, for consumers, for companies buying chips, is I think we're going to enter a world where the consumers probably need to pay for that resilience, because I mean, building fabs costs some money. If if a company has the fabs in one single location, that's probably the most efficient form of investment. But if now they have to diversify the geographical footprint, there will always be some slack in the system. It's not the most efficient form, but you trade efficiency for resiliency. But I think somebody needs to pay for it. But I think that's probably the cost worth paying for, given the rising global geopolitical tensions. But we'll see how it goes.
And speaking of geopolitical tensions and governments trying to protect their technology and IP, how realistic is it that countries like China and Russia will have to build their own EDA tools and even their own, EUV kind of technologies? Will they come to a grinding halt? What's your feeling on that? I mean, we're not trying to discuss the politics, but the technology aspects and the investments.
Yeah, I think semiconductor industry is probably one of the most globalized industry. I mean, you look at the list of the customers of let's say any of the manufacturing companies like Intel, right, or TSMC or Samsung Foundry, it's global. And if you look at the list of their suppliers, it's also global. There has been lots of localization efforts in terms of the supply chain. It's nothing new, but why all these leading chip companies, they end up having a list of global suppliers and global customers? It's exactly because you have to pick the best of the best as your suppliers, and you have to have as much of the global reach as possible, so to sustain the innovation. So this is the one thing I feel like this semiconductor industry was born with globalization, right? I don't think you will be able to sustain itself if you want to close up yourself and think about maybe I can localize everything. I don't think that's going to happen. It's unlikely to happen given the nature of this globalized supply chain and the globalized market. And that's a trend probably very hard to reverse.
Very interesting, very interesting. And I worked in global supply chains for Intel, and I had a different view when I was there from now. You mentioned the artificial intelligence, generative AI, 5G, 6G, IoTs are all happening at the same time. And that's one of the drivers for bespoke silicon, domain-specific silicon. Where do you see this going in terms of the overall growth of the semiconductor industry and the EDA industry?
Yeah, I would say for AI, right, it's a very hot topic. But behind AI, I think AI is not just about silicon. We are from semiconductor industry. Obviously, we look at the hardware, right, from a hardware angle. But from the players in generative AI, a lot of them are traditionally not the software internet companies, right? I think really going back to my point about Moore's law slowing down, and if everybody is buying from the same company for the same chip, they have to be able to differentiate on the software. But hey, look, I mean, Apple gave you the perfect example. Differentiating on software alone is probably not going to be enough. This software hardware co-optimization, this is through stack innovation, is going to be increasingly important into the future. So this is why even for AI, bespoke silicon, I think it's the future. But what that means to the semiconductor industry, to the ecosystem, I think you want to be the enablers of that trend. You don't want to go against that trend. How to enable that trend? You provide the necessary tools to that trend, You provide the necessary, basically the arsenal, right? There's a race right in front of us, the AI race. You want to be the arms dealer to that race because, well, how the race will play out, you never know. But, Gold Rush, you want to sell the picks and shovels. For EDA, you're exactly that picks and shovels supplier, right? And for EDA companies, this is going back to my point, you are no longer captive by the semiconductor industry. Everybody else who have a play in AI, everybody who knows the importance of the hardware software co-optimization, they're gonna come to you. They need your help. They need you to enable them to win the future of AI. Yeah, and I think that's a great opportunity for the EDA industry.
Interestingly, with the advent of AI, practically every single EDA company, semiconductor vendor, from Lam Research to Cadence Synopsys, is saying that they are incorporating generative AI, machine learning, deep learning. Do you see that giving tangible results? Is the profitability going to go up? Are the headcount going to reduce? What do you think is happening? What do you see
Well,
in the reality?
I think the reality, this is kind of going back to the invention of automobile, right? And compared with the horses. And well, if you're pessimistic, you see the invention of automobile, you're gonna feel like, okay, the world is no longer needs that many horses. Some people are gonna lose their jobs because of the invention of automotive. But actually, the opposite, right? It's the productivity improvement. I mean, in the EDA case, that's incorporating generative AI into the EDA tools. You're not gonna reduce the jobs for the engineers. You actually, because of the demand of semiconductors, you always have something to work on. You free up resources here because, well, you incorporated some generative AI features into your EDA tools, get a little bit better automation. You actually can deploy the talents, the engineers to design more complicated stuff. So I see generative AI as a tool, as something to help improve the productivity, to boost the productivity that actually will free the talents to do more challenging stuff. It's generally a positive for the semiconductor industry. And quite frankly, I think I came from a manufacturing background, but I did learn that probably chip design engineers is even harder to find because well, you need to know a lot of stuff. You need to know how computer science, and at the same time, you need to know about semiconductors. Well, that's a combination that's not very easy to find. And given the talent shortage, I think the more tools like generative AI related tools in EDA, that's a great plus for the semiconductor industry overall.
Yeah, looks like the geeks are becoming even cooler every day with all the changes. Speaking of geeking out, I know early on in your career, you did everything from STMs and AFMs to ALDs. I mean, I can't even spell out some of these things. So you have a good understanding of not only the fab and fab equipment side, but also the backend processes. How realistic is it to the chiplet strategy that many people are using, and also heterogeneous architectures, and combine that with maybe chiplets coming from different fabs? Is it realistic, or how long will it take to make it happen?
Well, I think chiplet is real. Very simple. I mean, you just cannot make larger and larger chips, either because there is always a limit in terms of the so-called reticle limit, right? 800 millimeters square. That's sort of the limit you can make in terms of how large the chip can be. But also there are lots of applications, especially battery-powered applications, consumer devices. You always have a form factor limitation, right? I mean, you can't have a big chip as big as your as your palm, and hoping that that can fit into the smartphone. There's just no way for that. You're going to end up with cutting up the monolithic chips at some point to put them into separate chiplets, either in a 2D or 3D way, depending on whether you have the form factor limit or not, right? For data center, that you go 2D, well, it doesn't matter, right? That you can have a big, gigantic package with the several chiplets inside. But in phones, you probably need to go 3D because, well, it's battery powered. A little bit more room for your chip means less room for battery. That doesn't work, right? Large chips doesn't work. So chiplet is very real. But I think the debate here is, can you have an open chiplet ecosystem? Let's say combining chiplets from different foundries and put them together into a package. I think it's hard for me to predict the future here, but my guess is the future will be heterogeneous. What do I mean by that? I'm not saying about heterogeneous integration. I'm saying the future won't be like homogeneous. Okay, everything will be in an open chiplet ecosystem. You can buy and sell from different vendors, plug and play, and put into a package. There will always be some companies pursuing a vertical integration strategy. Everything done by themselves. All chiplets are done by themselves. They put together themselves. All the IOs, how they integrate things together, are going to be proprietary. There will always be a part of the ecosystem to look like that, but there'll always be an open ecosystem there. So which one will win? Hard to tell. To be quite frankly with you, I mean, we have seen this kind of a debate on open versus closed for long enough time in tech industry, right? The very simple one, everybody knows. Your phone, there's a closed walled garden under Apple, which is great, but there's also an open ecosystem on Android, right? And both are coexisting today, and both can thrive. So I don't have a view on where the future is going to be in terms of chiplet. I'm only certain chiplet will happen, will proliferate, and will be the main form of architecture, at least for the most advanced compute systems.
It must be a huge advantage to be an analyst and also be deeply interested in the technology. So let me ask you another tech question that's related. Quantum computing has been a big story for more than 20 years. I remember VCs saying, if you're doing quantum, we'll fund you 20 years ago. But the real products are still yet to hit the market. What do you think is happening there? And is it realistic that we'll get some real quantum computers? And if so, how will it change the whole cryptography and confidentiality, security things?
Well, you are asking something that is reaching the end of what I know. This unfortunately is something I don't know too much about, but I will say this. I mean, innovation, I mean, people like to talk about innovation. When they talk about research and then the development, they think about those R&D in labs. But a bigger part of the R&D happens in factories. The lesson people can learn from the semiconductor industry is that manufacturing R&D on commercial volume is equally important, if it's not more important, than R&D happening in labs. So quantum computing, I think one problem one need to solve is this manufacturing innovation. So I think a lot of innovation in the early history of semiconductors, right, actually is about how to make stuff in high volume, in low cost. Right? I don't know whether quantum computing is where they are in terms of data manufacturing innovation, but my guess is probably a long way to go. The labs can always have published some fantastic papers, about the theory, about some of the simple implementation. Just kind of like transistors. Anyone can publish a paper on 1.4 nanometer cap or something smaller carbon nanotube transistor. But how can you bring that to mass manufacturing? That's a totally different question there. So quantum computing, I say, long way to go. But let's hope that manufacturing innovation can be accelerated. So the world would have an alternative if the Moore's law really hits an end.
Well, it's always fun to talk to someone who has both the engineering, business sense, scale up, everything. And we could go on forever. Do you have any concluding remarks for the future growth of semiconductors? Is it going to be less cyclical, or will it continue to be cyclical as it has been in the past?
Well, I think it will continue to be cyclical, but I would say I envision a future for semiconductors being high mix, low volume, lots of low volume for each of the type of chips, not the overall volume. Okay, the overall volume will grow. High mix, low volume, bespoke silicon likely will be the future. And I know lots of people are watching your channel, watching this conversation. I would say there's no better time to be in semiconductors. And when I joined the industry 2013, somebody did tell me, well, that's a mature industry. That's probably quote unquote sunset industry. But hey, look, 10 years later, doesn't look that mature at all. There's always something new happening to this industry, and it's becoming actually increasingly important. It's a foundational technology for the world's economy. So I think one thing I want to say is I kind of quit practicing engineering, right, by coming to Wall Street. But the other thing is I can see a much bigger picture, and I can actually appreciate how important my job at Applied Material was. Now I have a better appreciation of all the experience I had inside the industry, and I will continue to watch this industry to grow, and happy to be a partner of many of the people inside the industry going forward.
Indeed, indeed. I came back to the industry after a 6-year break, and I haven't had one day off because it's so exciting. With that happy note, I think it's time to conclude. I've learned so much from you, Charles, and to people out there who are listening. I'm always looking for interesting viewpoints, even divergent viewpoints. And please come forward. And thanks again, Charles. It's always fun talking to you.
Yeah, thank you, Shankar, and always happy to talk to you and appreciate all the things I learned from you. Thank you.